Welcome, 7th graders, to lesson 8-7, page 445 in your textbook. This is solving equations using addition and subtraction. So it's going to be similar to equations, but with not an equation, it's going to be an inequality instead. So it's almost the same as solving equations, but the property is that when you add or subtract the same number from each side of an inequality, the inequality remains true. Just like equations. So it's instead of the property of equality, it's the property of inequality. So you're going to do those same steps when you see a number. This reads a number minus 7, or 7 less than a number, is going to be less than 15. Okay? In an equation, normally you have one solution. Like only one value can equal n. In this type of situation, there's going to be a certain number of solutions that can make this true. Okay? It's always about making this true. So we do our inverse. If we want to move negative 8 to the other side, we're going to add 8 back on. So then we have n is less than 23. So what this means is any number less than 23 will make this true. You could check and do any number less than 23. You can't use 23 because 23 minus 8 would be 15, and this isn't a less than or equal to. So you could try 22, for example. 22 minus 8 should be less than 15. So then you'd get 14 is less than 15, and that's true. You could also try something more than 23 to show that anything 23 or greater will not make this true. So I could do 24 minus 8 is less than 15. Then end up with 16 is less than 15, which is not true. So n does have to be less than 23. So it could be any number less than 23. So 22, 21, all the way down to the negatives. So another one to try. Negative 4 is going to be greater than or equal to a number plus 7. What I can predict is that a has to be negative. For negative 4 to be greater, that means anything on the right will have to be less than negative 4. So negative 5, negative 6, and so on. So I'm going to still do my tracks probably to show that whatever I do to one side, I have to do the other. I'm going to undo adding 7 by subtracting 7. I'm going to see that that's the same as adding the opposite. So on the left, I get negative 11 is greater than or equal to a. So that means, and it has to be a number that's going to be less than negative 11. Numbers that are less than negative 11, you may need to think about. Now, if negative 11 is on a number line here, numbers that are less to the left are going to be negative 12, negative 13, numbers that are more negative than that. So you can check again. So it's going to be negative 11 or less. So say I pick a number that's greater than negative 11, see if that, or I'm going to pick a number that's less. So I'm going to say, okay, negative 12 plus 7, and I get negative 4 is greater than or equal to negative 5. That's true. But if I were to pick a number that is less than or more than negative 11, say, for example, if I picked 5 plus 7, I get negative 4 is greater than or equal to 12. Well, that's definitely not true. So I do have to stick with numbers that are less than or equal to negative 11. So anything more negative than negative 11. Here's a few to give a try. Using the same type of rules. So talking about properties of inequality. So we're looking for 12 is going to be greater than a number plus 3. So what number can I add to 3 and stay less than 12? Because 12 is greater than those numbers. So I subtract 3 on both sides. And I end up with 9 is greater than x. That means that x, if I rewrite this the other way, x has to be less than 9. So if I pick a number less than 9 and plug it in, 12 should be greater than, a number less than 9 would be 8 plus 3. So 12 is greater than 11, and that is true. So I did pick a number less than 9. Say I picked a number greater than 9, or 9 even. That's going to be 12 is greater than, say I picked 10. That's greater than 9. 12 is greater than 13. That's not true. So it does have to be a number less than 9. Always put that variable first. Again, on the other side, so we have a number plus 1/2 is greater than or equal to 4. So we're going to undo adding 1/2 on both sides. And we get that number is greater than or equal to 3.5. So n has to be greater than or equal to 3.5 for it to be greater than or equal to 4. Notice if you plug in 3 and 1/2 plus 1/2, that should be greater than or equal to 4. Well, 4 isn't greater than, but it is equal to 4. So 3.5 works. 3.5 works. I wonder if something greater than 3.5 would work. So if I tried 4, 4 plus 1.5 should be greater than or equal to 4. And 4 and 1/2 is greater than or equal to 4, so it's still true. Plug in something less than 3.5, so like 3. 3 plus 1/2 would be greater than or equal to 4. No, 3 and 1/2 is not greater than or equal to 4. So I just kind of proved my work that n, to make this part true, n has to be greater than or equal to 3.5. Last one, decimals are okay. You don't need a calculator. Now undo subtracting 1.5 by adding 1.5. So I get y is equal to, not equal to, see I almost went out of habit. So y, I keep my sign, is less than 3.5. So y is to be less than 3.5 for this to be true. And you can plug it back into check. Anything more would make their answer greater than 2, and we want our answer to be less than 2. Some word problems on 446. So the Airbus A380 can seat up to, important part, it can seat up to, mean maximum, 853 passengers. Suppose there are currently 632 passengers boarded on the airplane. Which inequality indicates how many more people are able to attend and to get on board? So you think, okay, the maximum, I always write, what is the limit? 853 is the limit. The number of people on board has to be, you're thinking that has to be the most it can be. Or you could write, what number of passengers plus those that are already on board is going to be less than or equal to the maximum amount of 853. So you have to think that that's the max, so you would never want the amount of people on board. You would never want this to be saying that the number of people on board can be greater than the capacity. You would never want more people on an airplane. That would not work out very well. So you'd show your work and you'd subtract, okay, without the 632 people already on board, how many more can fit? So then you rewrite, bring x down, and you end up with 221. So that means the number of passengers still able to board can be 221 or less. So the number of passengers is less than or equal to 221. So we couldn't have 222 people board because then we'd be over capacity. One more example. Our tornado is classified using the Fujita tornado damage scale, the F scale. is it called? An F1 tornado has wind speeds that are at least 730 miles, or 73 miles rather, per hour. An F2 tornado has wind speeds that are at least 113 miles per hour. Which inequality indicates how much the wind speeds of an F1 tornado need to increase to become an F2 tornado? So you think, yeah, 73 plus how many? What symbol do you think we need to become at least an F tornado? So to be greater than or equal to 113, because you think you have this F1 tornado plus how many more wind speeds to be greater than or equal to 113, because the tornado has to be 113 or more according to this at least statement. So then I subtract 73. This did take me some thinking. I had to pause, as you noticed, and I had to think about what the words meant. So then I get x has to be greater than or equal to 40 degrees. You have to get, the F1 has to gain 41 degrees or more to end up being 113 or more degrees. So it's going to be F as our answer. This lesson does take some reading and some thinking about situations, so make sure that you're careful and you're not careless and you take your time. Rewatch this, watch Mr. Lentz or Miss Haas, and look at the examples in the book or check something out online. Good luck.